So chapter 6.4 talks about the properties of the log function, and it asks us to state the domain, the range, and the vertical asymptote of each logarithmic function. So the domain is defined by x values that you can plug in that don't give us undefined y values. And we know that log, if we take the log of some x, where x is equal to or less than 0, then this is going to give us an undefined y, or an undefined f of x, which means that everything inside this log, this expression here, must be greater than 0. So we can find the domain of each of these functions by solving the inside and setting it equal to, So we can find the domain by setting each expression inside the log greater than 0 and solving for x. And then we know for range that the exponential graph has a domain of negative infinity to infinity, or all real numbers, and then the range is from 0 to infinity for our parent function. And since the log is the inverse of the exponential function, then these are going to be flipped. The range is going to be negative infinity to infinity, or all real numbers, and the domain is going to be 0 to infinity. So that holds true for all of these functions. And then finally, for the vertical asymptote, we just need to find where the domain is restricted. So for f of x, we have log base 4 of x plus 8, and then we can find the domain by setting this expression here greater than 0. And if we solve for x, we get x is greater than negative 8. So the domain is going to be from negative 8 all the way to infinity. Then the range is going to be all real numbers, so negative infinity to infinity. And then our asymptote is going to be at x equals negative 8. And g of x gives us log base 2 of 3x plus 8, and then minus 6 on the outside. So if we take this and set this equal to, or set this greater than 0, we have 3x plus 8 is greater than 0. I subtract 8 from both sides, and then divide by 3. Then we get x is greater than negative 8/3. So this is going to define our domain. To infinity, range is everything, and then x is going to be this negative 8/3. And then we have the same for this. 10 minus 2x is greater than 0. So if we subtract 10 from both sides, we get negative 2x is greater than negative 10. Now when we divide by negative, remember that the sign flipped. So in this case, x is less than 5. So our domain is going to go from negative infinity all the way to 5. Then the range is everything, and our x is going to be 5. That's a vertical asymptote. Then for k of x, we have log base b, any b, of x minus 7. And we can set this greater than 0, so x is greater than 7. And that's going to be our domain. Our range is everything, and then x is 7. So same here, we do 2x is greater than negative 3, x is greater than negative 3/2. So our domain is this all the way up to infinity. Range is everything, and this also defines our vertical asymptote. And the last one is going to have this vertical flip, so that actually doesn't change the domain or the range for that matter. And that is going to be moved up 5, which again doesn't affect anything. And the only thing that does is this 2x plus 12 in the middle. So 2x plus 12 greater than 0. We have 2x is greater than negative 12. So x is greater than negative 6. And that gives us our domain. Range is the same as usual, and then our vertical asymptote is at negative 6.